Graham's law states that the rate of effusion or diffusion to a gas is inversely proportional to the square root of its molar mass, meaning lighter gases move faster than heavier gases under the same conditions. The key components of Graham's law include effusion, which is the process where gas molecules escape through a small hole, and diffusion, which is the mixing of gases to form a homogeneous mixture. A related field to Graham's law is inorganic chemistry. Inorganic chemistry is concerned with the properties and behavior of inorganic compounds, which include metals, minerals, and organometallic compounds. Inorganic chemistry relates to Graham's law because the law can be applied to compare the rates of diffusion and effusion of various inorganic gaseous compounds. Thomas Graham was born December 20, 1805, and died September 11, 1869. During his life, Thomas Graham had several accolades. While his father wanted him to be a minister, Thomas had other plans for success. Throughout his career, he was able to accomplish many things. Graham became the first president of the Chemical Society of London. However, when he became the master of mint, it was reported that he stopped his research for several of years to take that position very serious.
Graham's law deals with diffusion and effusion of gases. It's inversely proportional to the square root of its molecular weight. So effusion is when air escapes through a small hole. This causes the molecules to collide, and diffusion is the movement from a high concentration to an area with low concentration. So think of like a essential oil diffuser. You're taking the high concentrated oil and diffusing it into the air of, say, your living room to make it smell better. My related field is chemical kinetics. This is the study of the rates and mechanisms of chemical reactions. So of course, when you're dealing with chemical reactions, especially with gases, the Graham's law explains how the speeds of gases can vary, which in return helps the study of chemical kinetics involving gas exchange. My relevant scientist that I chose is Adolf Fick. He was actually the youngest child in a very large family. He was really smart in math and physics. Most of his siblings went to law school, but he was one of the only ones that actually went into physics. And he introduced his laws of diffusion at just 26 years old. So he kind of incorporated Graham's law into his Fick's law by affecting the diffusion constant. So Fick's law is actually the diffusion of gas across a fluid membrane.
Hi class, I'm Marie Lopez and I'm going to be going over Graham's law of diffusion. States that the rate at which a gas effuses or diffuses is inversely proportional to the square root of its molar mass. In other words, lighter gases move faster than heavier gases. The relative field that I went over was kinetic theory of gases. It explains molecular motion and speed distributions. The kinetic theory explains the behavior of gases by assuming that gas particles are in constant random motion. The particles are very small compared to the space between them, and they move in straight lines until they collide with each other or the container walls. Collisions are perfectly elastic, meaning no energy is lost. The pressure of gas comes from these collisions with the container walls, and the average kinetic energy of the particles is directly proportional to the gas's absolute temperature. The relevant scientist that I went over was John Dalton between 1766 and 1844. His atomic theory helped explain why gases of different masses effuse at different rates. He was an English chemist and a meteorologist best known for developing the atomic theory, which proposed that all matter is made of indivisible atoms. He also formulated Dalton's law of partial pressures and made major contributions to the study of gases. Dalton was the first to scientifically describe color blindness based on his own conditioning and kept detailed meteorological records throughout his life. His work laid the foundation for modern chemistry and physics.